Hello students. Today we are going to discuss the topic that is instantaneous center of rotation. We usually call it as ICR. So there are some fundamental things which we are going to learn in this ICR. So before starting, uh, why there is need of ICR, that we will discuss. The ICR is located, that is instantaneous center of rotation is located in order to find out velocity and further acceleration. So this is finding ICR is one of the tool for finding velocity of any link in the mechanism. So this is one of the method of finding velocity of any link in the mechanism. Now this method is based upon the concept that displacement of any link having a motion in one plane is considered as pure rotational motion, and the complete motion is about some particular center, and that center is nothing but instantaneous center of rotation. So whether that link is having a translatory motion or it is having a pure rotational motion, in both the cases it is assumed that the whole link is rotating about a particular center, and that center is called as a instantaneous center of rotation, which is also called as virtual center of rotation. So if you observe this diagram, here you can observe, you can consider AB as one of the link which has moved from its position, that is end A has moved to A1 and B has moved to B1. During this motion, the motion consists of a pure translatory motion, that is from A1 and B dash, and after that there is a rotational motion about a center A1, that is point B dash has moved to B1. So it is a combination of two motions. One is translatory motion and other is rotational motion. Now if I consider only rotational motion from B dash to B1, the center of rotation is A1. But if I consider a combined motion of point B from B to B1, then what will be its center of rotation? So that center of rotation will change time to time. That's why it is called as instantaneous center of rotation. That will be particular for any position of link in the mechanism. In second diagram, the motion is again consist of two types. It is of two types, that is link is initially having rotational motion, that is point B has moved from B to B dash, and then there is a translatory motion from B dash to B1. So in this case, the instantaneous center of rotation can be found, and it can be obtained as the figure shown below. If I connect point A to A1 and B to B1, and if I draw a bisector from line A to A1 and B to B1, their intersection of the bisectors will be, say, at I, then that I is nothing but the instantaneous center of rotation for that particular link. So here the motion consists of translatory as well as rotational motion, and we are assuming that it is a pure rotational motion which is about a center, that is I, which is called as instantaneous center of rotation. Now, how to find out number of instantaneous centers in the mechanism? So number of centers in the mechanism is nothing but it is number of possible combinations of two links. So mathematically we can write it as n is equal to small n into n minus 1 divided by 2, where n, that is in capital letters, is representing number of instantaneous center, while small n is representing number of links in the mechanism. Coming to the next, that is location of instantaneous centers. So in first diagram you can see, if there are two links connected to each other by a pin joint, then the instantaneous center of rotation lies at their joints, that is I12 is representing instantaneous center of rotation for link 1 and 2. Second example, if you take, in this there is a pure rotational motion, that is a disc is one of the link and which is rolling over a surface, that is another link. So its instantaneous center of rotation always lies at a point of contact between disc and that surface, that is I12. If you take third example, in this example, if there are two links having a sliding contact, then the instantaneous center of rotation always lies at infinity, which is perpendicular to the surface over which the second link is moving. So here link 1 is fixed, which I have assumed as a surface over which this second link is moving, which is having complete translational motion, then its instantaneous center always lies at infinity. So these are the various positions where the instantaneous center of rotations lies. These are some examples. Coming to the next point, that is type of instantaneous centers. There are three types of instantaneous centers. One is fixed instantaneous center, second is permanent instantaneous center, and third one is neither fixed nor permanent instantaneous center. So we'll see one by one. Now if I consider a 4-bar mechanism which is shown in this diagram, so there are 4 links. Link number 1 is fixed here. This is your second link, third and fourth link. So if I want to calculate number of instantaneous centers, I can use the formula, that is n is equal to n into n minus 1 divided by 2, which we have discussed earlier. So by this we'll get number of instantaneous centers equal to 6. Out of these 6 instantaneous centers, some of the instantaneous centers will be marked by observation and remaining can be marked using Kennedy's theorem. So what are the different instantaneous centers that can be marked by observation are? The first one, that is I12 and I14. So these are at pin joint. So link number 1 and 2 here is connected at point D. So this I12 is a fixed instantaneous center. Similarly, link number 1 and 4 is having a pin joint at I14. So it is also a fixed instantaneous center. So what is fixed instantaneous center? It is an instantaneous center which remains in the same place for all configurations of mechanism. So even if there is a change in configuration in the mechanism, the instantaneous center which remains at its position, that is called as fixed instantaneous center. So generally it is always located to the fixed link. So link number 1 is fixed. That's why the ICR which are related to link number 1 are fixed ICRs. Coming to the next, I23 and I34. So here you can observe I23 which is between the link 2 and 3, that is a pin joint, and I34 is a pin joint between link number 3 and 4. These two ICRs are called as permanent instantaneous centers. So what is permanent instantaneous center? These instantaneous centers moves when mechanism moves, but the joints are permanent in nature. So when the configuration of the mechanism changes, at that time their location is always at a pin joint, that is at pin joint of link number 2 and 3 and link number 3 and 4. So they are not remain at a particular position always. As configuration changes, their position also changes, but it is always at a pin joint between the two links. That's why these are called as permanent instantaneous centers. The remaining two are I24 and I13. The instantaneous centers which are neither fixed nor permanent are called as neither fixed nor permanent instantaneous centers. So remaining all are neither fixed nor permanent type of instantaneous centers which can be found or which can be located by Kennedy's theorem. So these instantaneous centers varies with the configuration of mechanism. So at every instant or when the configuration of the mechanism changes, their position is also changing, and that is called as neither fixed nor permanent instantaneous centers. Remember, during the discussion I always use the notation as I23, I34, I13, I24, I12, I14. So reading instantaneous centers is like this only. You should not read it as I12, I14, I23, I34. So that you have to remember. Thank you.